Assume that we're trying to move this block in this direction by applying a force at an angle, for example, theta. So then the friction between this block and the surface is going to act to the left direction because we're trying to move to the right. And then the normal force is going to act upward. And then friction force, again, we know that friction force is equal to the friction coefficient times the normal force. And then we can resolve this P into two different directions. In this direction, it's going to be P sine theta. And in this horizontal direction would be P cosine theta. So if we write now summation of Fy is equal to 0, then we can say plus N, normal force acting upward, minus P sine theta acting downwards, minus W. And that's everything we have in the Y direction, everything summed to 0. So then we can write N is equal to W plus P sine theta. This is our equation number 1. If we write Fx is equal to 0, then we have the P plus P cosine theta to the right direction, and then minus F, that's the two forces we have in X direction. Everything summed to 0. So then P cosine theta minus F, which is the mu N, normal force. So then P cosine theta minus mu. If we plug the value of N from the equation 1 in here, then we get W plus P sine theta. Everything summed to 0. So then we can write P cosine theta minus mu sine theta minus mu W is equal to 0. So now we can solve for P, which would be mu W divided by cosine theta minus mu sine theta. So using this equation, we can calculate the value for P. Now assume that, let's say, theta is 30 degree. The friction coefficient is, say, for example, 0.2 between the surface and the block, and the weight of the block is, say, 1,000 pounds. If you plug all these numbers here, 0.2 times 1,000 divided by cosine 30 degree minus 0.2 times sine 30 degree. Then the value for P I found 261 pound force. So this is the 261 pound needed just to initiate the movement. You're not going to move. It is still a static position just to impede the motion to the right direction.